Interesting fact. I grew up with Jack in the Box in California. That's where I grew up. My dad was born in Salt Lake, so I'm still a Utahan, but I was born in Santa Ana, California. And I love Jack in the Box. Back then, it was like $1 for a chicken sandwich, $1 for a jumbo jack burger, 2 tacos for $1. And so, amazingly, on the day of my birthday, right, January 20th, just a week and a bit ago, Jack in the Box opened right by my house, 15 minutes from my house. I'm so excited. Woo, Jack in the Box in Tremonton. Wayo. And I went to the grand opening. And I got $20 worth of stuff, and then it was only cost me $10, half price for the grand opening. So I kept the cup. So thanks for letting me share that with you. We're on 7.3. So 7.3. So 7.3 is has to do with solving. So solving logarithms, and no, that's 7.4. Sorry. So 7.3 is actually, it's got some solving in it actually, but mostly just properties, which prepares you for solving. So you're gonna like this one. Lots of different properties to help you to be able to do things with logarithms, right? Okay, let's see. So do you remember how to factor? Yeah, pull out the GCF and factor it. So pause me and go and try number 1 on your own right now, okay? Go and pause me and try number 1. Pull out the GCF, pause me. What do they have in common, right? What do they have in common? They probably have a 5 in common. No, they have an x in common. Pull out an x. Factors of 25 are 5 and 5. Plus and plus. And they want you to solve each equation. So we're going to set this guy equal to 0. Excellent. And then this guy, set it equal to 0, and you get a -5 and a -5. So just 0 and -5 is our solution. Nice. So try number 2 now. Add 27 to the other side. And I'll let you go ahead and factor it. Go ahead and factor it, right? Get everything on the same side and factor it. What are factors of 27? You got this, you got this. Okay, let's see here. Whoa, do you remember how to do compositions? ACTs are coming up. How do you do compositions? Well, you have f of g of x. So you're going to take g of x and plug it in there in place of the x. So it'll be x minus 2 all squared. X minus 2 all squared plus 3. And so, don't forget, there's 2 of them. Pause me, try it on your own. Pause me. So it means you have to distribute it. So x squared minus 2 times x is minus 2x. Another minus 2x is minus 2x, and then a plus 4. Combine like terms. So x squared minus 4x plus 11? No, plus 4 plus 3. 4 plus 3 is 7. There we go. Okay, so try the next one on your own. Give it a try. So this is doing g of f of x, basically, is what that one's doing. Don't forget that the O just means composition. Just means composition. 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 Yeah. Okay, there we go. Ooh, so they want you to plug x equals -2 in for x. And they want you to plug it in there. So f of x is x squared plus 3. So you're going to do -2 squared plus 3. -2 squared plus 3. So don't forget, a negative times a negative is a positive. Pause me. Try it on your own. Try it on your own. -2 is a 4. Plus 3 is 7. That's not the final answer, though, because you got to plug it back in. Got to plug it back in again. So now we're going to do x equals 7 now. Input output becomes the input, final output. Do you remember compositions? So 7 squared plus 3 is going to be 7 squared is 49 plus 3 is what, 52? 52. For number 5, try the next one on your own. Keep on trying. Pause me. Try it on your own, okay? Try it on your own. So number 7 now, number 7. So we're just going to go ahead and graph the parent function, then go up 3. Oh, that sounds so much easier, Mr. Newble. That sounds so much easier. So graph the parent function and then go up 3. Okay, we could do that. So we get y is equal to log base 4x. Now remember, we could go ahead and rewrite this as an exponential. And so how we do that is we go ahead, and this is our solution. Y is our solution. And so we're going to do base 4, right? So we have log base. No, that's not the solution. That's the exponent. So 4 to the y power. So 4 to the y power equals x. Wayo. And so if you're not sure how I did that, I'll show you up here. So we have y equals log 4 to the x power, 4 to the x. And then what you do is you base 4 both sides, right? So we're going to go ahead and base 4 both sides, base 4 both sides. And that gets rid of the log base 4. And now we have x equals 4 to the y power. Cool. Just like that. So you can rewrite these things, okay? Rewrite these things. Good. Okay, so then we just do an xy table. And we use xy table. We use values for y though. So 0, no. We're going to go -1, 0, and 1. And so now we're going to rewrite this. It's going to be x equals 4 to the y power. So x equals 4 to the y power. X equals 4 to the y power. X equals 4 to the y power. Where our y power is red. So yeah, so we're going to use y. And so we're going to use -1. And so that's -1. And that's 0. And that's 1. So we're plugging in y values. We chose a little bit to the left and to the right with our y values. Not left and right, up and down for our y values. So -1 and 0 and +1 to see what the graph's doing. And so 4 to the -1 is just a 4th. 4 to the 0 is just 1. And then 4 to the first power is 4. So we're going to go over 4th, down 1. Over 1 up 0, over 1 up 0. And then over 1, 2, 3, 1, over 1, 2, 3, 4, up 1. And there's our graph. So that's our parent function. That's our parent function. And now we're going to go up 3. We're going to go up 3. So that means that this goes up 1. This goes up 1, 2, 3. This goes over here up 1, 2, 3. And this one down here, right? This one down here goes up 1, 2, 3. And there's our graph. So it's still going down, still going down. Really close to that x-axis. And then we go up and over. Wayo. And so our domain is from 0 to the right forever to infinity. Our range is down forever and up forever, slowly up forever, but still up forever. And then our asymptote. Our asymptote is x equals 0. Because we're along the x-axis there, along the x-axis is our asymptote there. There we go. So there's our asymptote there. I'm drawing the lines like that, but really, you could probably just do like, if you had colors like me, you could just go like that. Cool. So at x equals 0 is our vertical asymptote. So that's review, right? That was review. So I hope you got it right. Try number 6 and try number 7, try number 8. So 8 is actually going left 1, down 3. Number 6 is actually going right 2. And then this would be y equals ln of x minus 2. And so that's going to be right 2, not left 2, right 2. So we're going to do the parent function first, which is just ln of x. And then to undo ln, you base e, 2.718. So you base e both sides. That gets rid of the ln of x. And so x equals e to the y power is what you're going to do. And you choose values for y's. So that's going to be -1 and 0 and +1. So go ahead and give that a try. You got this. You got this. And now for our new lesson. Way-o, new lesson. So use properties of logarithms to simplify each expression. And we're doing properties of logarithms. And so we learn with properties of logarithms that if you go ahead and, for example, if you log base of a number with a number with the same base, right? With that same base number, and then you have an exponential there, for example, 3x plus 2, then the log base is going to undo the base, and that'll just be our answer. So log base 4 undoes base 4, so we're just left with 3x plus 2 as our answer, right? And I'll go ahead and prove it to you with our calculator there. So let's go ahead and try. Let's see here. And so we're going to do, let's try a base. So let's see, let's try an example, like, I don't know. So log base 4, that didn't work. So we're going to go math button, and we're going to go ahead and do, so we're going to do math button, do log base 4 of base 4. And it doesn't matter what the exponential is, it could be 100, it doesn't matter. So log base 4 basically undoes base 4, and all you're left with is 100. Or in our example for number 9, all that's left is 3x plus 2. Way-o, 3x plus 2. Cool. So another example, it doesn't matter which number it is. So it could be 12. And then you have 12 to some number. And so all it does is get rid of the base, right? All it does is get rid of the base, and you're just left with the exponent. Cool. Same with number 6, but number 6 is the other way around. So base 6 gets rid of log base 6. Another example for like number 10, for example, could be, I don't know, let's do 5. And so 5 to the, right, 5 to the log base 5 of no matter what it is, you know, some number, doesn't matter what it is, 100, just some number. So log base 5 undoes base 5, and we're left with 100, for example. Cool. So now let's see here. So we have e to the ln of the x. If it was e to the ln of like 5, for example, those would cancel each other out. Just gives you a 5, for example. So basically, e and ln undo each other, right? So basically, it's basically e to the log base e is what that is. And so it doesn't matter whatever number it is. It's just another example. And so e undoes log base e, same with e to the ln, right? Also undoes each other, because ln is just the same as log base e. They're the same. They're the same. What about this guy? Oh, well, this is 7 times ln of e to the 0 power. And so basically, this is the same as 7 times log base e. And so log base e undoes base e. And we're just left with a 0. And 7 times 0 is 0. So try number 10 on your own. Try number 11 on your own. Give it a try. Properties of logs are pretty cool. So the base gets rid of the log, and then the log gets rid of the base. Interesting. Interesting. So then go ahead and try the next ones on your own. So we can rewrite logarithms as well. We can rewrite logarithms. So you start with a base.